Hi everyone, let's start example 2. So again, I'm going to show you how you can solve for the sides of a 45, 45, 90 triangle using both the Pythagorean theorem and these nifty ratios. Remember, these ratios only happen if you have a 45, 45, 90 triangle, so just be careful. Alright, so I'm going to show you again by using the Pythagorean theorem. Good golly. Pythagorean theorem. And by using the ratios. And again, you guys, I'm not going to show you it again, but a third way you can solve is by using sine, cosine, and tangent. So again, you have options. So after we do several of these, you can kind of decide, well, I prefer by solving with trig functions or by using the Pythagorean theorem or by using the ratios. Okay, I will never make you solve it in one way. You get to pick which way you like the best, which I know is going to be a hard decision because all three ways are pretty cool, right? I know. Okay, well, let's get started. So example 2. Let's start by solving using the Pythagorean theorem. Which Pythagorean theorem? The a squared plus b squared equals c squared. Okay, the A and the B are the two sides of the right angle, which it doesn't matter which one is the A and the B. So I'll call this one the A and this one the B. The C is the side directly across from the 90-degree angle, which is the hypotenuse, which is the C. Okay, now if you're looking, you're probably like, Miss Long, I only know one of the sides of this right triangle. Well, these two tick marks right here means that these two sides are congruent. So if this one's 9, it means also that this side is 9. And since I have an isosceles right triangle, because I know two sides are congruent, which means it's isosceles, that means these two angles have to be 45 degrees. Isosceles right triangles are always 45, 45, 90. So this is letting me know I can solve by the Pythagorean theorem or the ratio, or technically with sine, cosine, tangent, whatever you prefer. Okay, well, let's get started. So currently the A and the B are both 9, so this will be 9 squared plus 9 squared equals c squared. Well, I don't know c, so I'm going to call this side x since I don't know. Okay, so x squared. Alright, well, 9 squared, 9 times 9 is 81. And so I'll have 81 plus 81 equals x squared. Alright, 81 plus 81, that will give me, let's see here, 162 equals x squared. Let me double check that. Yes. Okay. So now I need to solve for x, which currently the squared is getting in the way. Okay, we add these together. Okay, so the way that you undo a square, the inverse of a square is to square root. And if we square root one side of the equation, we got to square root the other side. Okay, so we're going to have the square root and the squared will cancel out. Now, I like to write my x first. So I'm going to write this answer on this side. So I'll have x equals, remember when you square root both sides of an equation, what will appear on the other side of your equal sign? That would be a plus or minus. Alright, then we're going to have the square root of 162. Which, what do you guys think, is 162 a perfect square? No, it is not, which means we have the lovely opportunity to do a factor tree again and simplify down our square root. Yes, we love factor trees, so let's do it. Alright, so my factor tree I'm going to do over here. So let's break on down 162. Well, I know it's even, so I know definitely 2 will divide into it. So 2 and 81. And 81 will break down into 9 and 9. And technically, since I see 2 of the same numbers, I can stop. Now, you could break this down into a 3 and 3 and a 3 and 3. But 3 times 3 is 9. So I'm going to stop here since mathematicians like to be efficient. I have one pair right here, which is a 9. And then my lonely single 2 has to stay in for the nights. Okay, so my answer is going to be 9 root 2. Okay, and remember, technically, since we're solving for the sides of a right triangle, the only answer that makes sense is the positive version. So my final answer will be x equals 9 root 2. Alright, so we know our missing side already, but I'm also going to show you that you can solve using the ratio and you'll get the same thing, so get excited. Alright, our ratio for a 45, 45, 90 triangle is 1 over the leg equals root 2 over the hypotenuse. Okay, which the legs are the two sides of the right angle, so this is the leg and this is the leg, which in a 45, 45, 90 triangle, they're always the same. And then the hypotenuse is the side directly across from my 90-degree angle. Alright, let's set this bad boy up. So 1 over the leg, well, both legs are 9, so it doesn't matter which one I picked, equals root 2 over the hypotenuse, which is x. And since I have a ratio equal to another ratio, guess what? I get to cross multiply. So let's do it. So 1 times x will give me x. And that will equal the other way. 9 times root 2 is 9 root 2. And look at that, you guys. I'm already done. So I get x equals 9 root 2. Which if you see, these are the same exact answer. So if you guys see, sometimes the ratio saves you a whole lot of time. Sometimes the Pythagorean theorem will. And then sometimes sine, cosine, and tangent is the fastest way. So really it just matters which method you like to do best. I will say one advantage to using sine, cosine, and tangent is that it works in any right triangle. Okay, the Pythagorean theorem only works if you know two sides of your right triangle, which in this case you can in a 45, 45, 90 triangle. And then this ratio will only work in a 45, 45, 90 triangle. So that's the only downside to this. But if you guys see, it took no time to solve for my missing side. So sometimes using the ratios can be very beneficial. So there you go. Wasn't that awesome? Not as awesome as example 3 and 4, right? So I'm already excited to do example 3 and 4. So let's get moving.